we are going to start now the next chapter, chapter 15 of class 10th mathematics. It is probability. In class 9th, we have studied the chapter of probability, and in that chapter we have studied the empirical probability. Empirical probability means it was a probability which was based upon some experiments. It is also called the experimental probability. We are saying, suppose we have tossed a coin 500 times and the outcome we have obtained, it is 240 times we are getting it is heads and 260 times we are getting it is tail. Now the probability of getting the head, we are saying the favorable outcomes, it is 240 divided by the total number of outcomes, it is 500. So the answer we are getting it is 12 by 25. So based upon this experiment we are obtaining this value of the probability. Now suppose in place of getting this we are getting 260 heads and 240 tails. So the probability will change and the answer will become 260 by 500. If the experimental outcome will change, the value of the probability will change. So this kind of probability, it is called empirical probability, or this is called the experimental probability. Now in this chapter we are going to study about the theoretical probability. Theoretical probability means that this problem that we are facing, that with the change in experiment the value of the probability is changing, that is the value of the chance. We are saying the chances of happening that particular event, it is changing. So to overcome this problem we are going to deal with the definition of theoretical probability, and we will solve the problems based upon this. Now the definition of probability we have, it is probability is a concept which numerically measures the degree of certainty of occurrence of an event. So before defining the probability, we define some basic terms. These terms we have already studied in our previous class also, or in previous videos also. So the first term we have, it is the experiment. So we are saying an operation which can produce some well defined outcomes is called an experiment. Any kind of operation which can produce some well defined outcome, it is experiment. Next we have is the term random experiment. So we are saying an experiment, random experiment is an experiment in which all possible outcomes are known and the exact outcome cannot be predicted in advance. We are saying the exact outcome that cannot be predicted in advance, that kind of experiment, it is called the random experiment. So if we are saying we are tossing the coin, we are saying we have tossed coin 500 times, whatever outcome we have obtained, we cannot tell what we will get the outcome if we will throw the coin 500 first time. So this kind of experiment, these are called the random experiments. The next term we have, it is trial. Trial is performing a random experiment. The process of performing a random experiment, that is called the trial. So some examples are given over here. We are saying if we are tossing a fair coin, then it is a trial. Next we are saying rolling a unbiased die, that is a trial. Drawing a card from a pack of well shuffled cards. We have 52 cards in the deck, and if we are, without looking at the cards, if we are taking out a card or drawing a card from this deck, then that is also an example of a trial. Then we are saying picking up a ball from a bag of balls of different color. This is also an experiment we are performing. These all are examples of the random experiment, and that one particular performing that experiment, that is the trial. This picking up a ball, it is the, we have picked a ball, it is a trial, and this picking up of a ball from a bag of balls of different colors, it is a random experiment. Now next we are giving some details about these experiments. So first experiment we are talking about, it is tossing a coin. So the outcomes that we can have, we are saying if we toss a coin, the outcomes that we can have, either it is a head or a tail that can appear on the upper face. Second we are talking about, it is throwing a die. So die is a solid cube having 6 faces which are marked with the numbers 1 to 6, and either these numbers are marked or there are dots. There are 1 dot, 2 dot, 3 dot, 4 dot, 5 dots or 6 dots on its faces. And when we throw a die, whatever face that is appearing up, we look at that number. When we note that number, we are saying the outcome is the number or the number of dots appearing on the uppermost face. That is the plural of die, it is dice. Next, the third experiment we are talking about, it is drawing a card from a well shuffled deck of 52 cards. So when we are talking about the cards, we are saying there are total number of cards we have, it is 52. This thing you should remember, the total number of cards we have, it is 52. And there are 13 cards of 4 suits. The 4 suits that we have, they are spades, clubs, hearts and diamonds. This is explained on our next slide. We are saying the 4 type of cards that we have, they are spades and clubs, hearts and diamonds. These are the hearts, these are the diamonds, these are of these two, these are of red color. So how many diamond cards are there? 13. How many hearts are there? 13. How many red cards are there? It is 26. Then we have the black color cards, and these black color cards we have, they are the spades and the clubs. So spades means we are talking about these cards, these are the spades and these are the clubs. So how many clubs are there? 13. How many spades are there? 13. The total number of black cards we have, they are 26. Next we have the face cards. The face cards, we mean to say these cards, the jack, queen and the king. These cards we are saying these are the face cards. So the total face cards we have, these are 12 cards are the face card. If we are talking about the red face cards means we are talking about these cards only. So number of red face cards we have, they are 6. And the number of black face cards, these cards we are saying the black face cards, it is also the number of black face cards, they are also 6. We are talking about the face cards that are diamonds. We are saying these are face cards that are also diamonds. So we are saying how many cards we have, it is 3. So you must remember all these values. One thing to note over here, this A we are saying this is not the face card. This is not the face card, and this is even not the number card. When we are saying we are talking about this A, it is neither it is the face card nor it is the number card. So these things you must remember while solving the questions. Next we are talking about looking at the all possible outcomes in various experiments. So we are saying, if suppose the first experiment we are talking about, it is toss a coin, then the possible outcomes that we will have, it is either a head or a tail. When we are talking about tossing 2 coins, the possible outcomes there, either we will get head on both the coins, we can get one head, one tail. The first is head, second is tail, or both of these are tail. So we are saying HH means that on the first coin we are getting the head, on the second coin we are getting the head. In this case we are saying on the first coin we are getting the tail, on the second coin we are getting the head. So these are the first and second coins we are talking about, and H and T, they are representing the head and tail. So what we are saying over here, that 2 coins are tossed simultaneously, and we are saying these are the all possible outcomes. Next we are talking about, it is rolling a die. Now rolling a die means the possible outcomes that we can have, it is these numbers can be possible outcomes. Either on the upper face we can have the number 1, 2, 3, 4, 5 or 6. So all possible outcomes, these are mentioned over here. Next is drawing a card. So if we draw the card from the deck of 52 cards, the total number of possible outcomes is 52, that we can obtain any of those cards. Next is the term event. So event is the collection of all or some of the possible outcomes. It is the collection of all or some of the possible outcomes, that is an event. So if we are saying we are talking about throwing a coin, then H is an event of getting a head. H is an event. Suppose we are talking about throwing of two coins simultaneously, and E be the event of getting at least one head. So at least one head means we are saying either both of these are head, so there is at least one head. It is HT and TH. These are the three events we are talking about. These are the three events we are talking about when we are saying there is at least one head. There is at least one head over here. There is at least one head over here. There is at least one head over here. So these E contains HT, TH and HH. Next term we have, it is equally likely events. So a given number of events are said to be equally likely if none of them is expected to occur in preference to the others. Now suppose I am talking about the tossing of a coin. We are saying H and T, these are the two events, and there are equal chances either head can occur or tail can occur. If we are talking about throwing of the dice, we are saying 1 can occur, 2 can occur, 3 can occur, any of these numbers up to 6 can occur over here. So all these numbers, the occurrence of all these numbers, they are equally likely. We are saying equally likely over here. So equally likely means that any one of them is expected to occur. The expectation, the word expectation we cannot use over here because in probability expectation has some other meaning. So we are just using the term over here that the chance of occurrence of all these terms, they are same. So this thing is mentioned over here. If we roll an unbiased die, unbiased means that we have not changed the shape or weight of that from one side. The chances of when we throw the dice, we do not know which face will come up. So that kind of die, that is called the unbiased die. So we are saying each number is equally likely to occur. If however a die is formed that a particular face occur most often, then that is called a biased die. So if suppose I am talking about that in place of the cuboid we make it in this form, that one of its faces, it is larger. We are saying this face, we are saying this is larger than all other faces, or we are saying this face we have made, it is smaller than all other faces, then the chances that this face will come downward, it is less. So in these kind of cases, when the dice has, when one particular face has more chances of coming up or down, that kind of die, it is called the biased die. Similarly, if I am talking about the coin, suppose we are having the coin, and what we have done, we have put something round over here like this. So this kind of coin, it is called the biased coin. Or we have put some weight on one side of the coin, it will make it biased coin. It means now the chances of occurrence of both the events H and T, they are not same. One of them is more likely to occur than the other. So we are saying the outcome are not equally likely to happen when the object we are talking about, either it is the coin or it is the dice, it is biased. Now the next we have, it is the definition of the probability of occurrence of an event. So it is the definition we have, E of E means event E is there. This is the event E we are talking about, and probability of E, this is method of writing probability of E. The definition we have, it is number of outcomes favorable to E divided by the total number of possible outcomes. We are in our, when we are talking about the empirical probability, we are saying that we have performed some experiment, and based upon that experiment we were calculating the number of favorable outcomes. Now we are not performing any experiment over here. We are talking about the total number of outcomes favorable to E over total number of possible outcomes. So this is the definition of the probability that we are going to use in this chapter. The next term we have, it is the sure event. So we are saying that if suppose I am talking about the single toss of a die, and the event we are talking about that we will obtain a number less than 7. So what is the probability of this number? The total number of possible outcomes, it is 6. It can be 1, 2, 3, 4, 5 or 6. And when we are talking about the number of favorable outcomes, number of favorable outcome means we are talking about what we are trying to find is we are trying to find the probability of the event, and the event is to get a number less than 7. We are saying all these numbers, these are less than 7. So all these are the favorable outcomes. So number of outcomes, favorable outcomes, we have 6. So the probability we obtain it is 1. So this kind of event, it is called the sure event. So we are saying the probability of the sure event, it is 1, that we are sure. When we are saying getting a number less than 7, we are saying when we throw the die, the numbers will be 1, 2, 3, 4, 5 or 6. It means this event we are talking about, this is the sure event, and the probability of the sure event, it is equal to 1. Next we have is the impossible event. So if suppose we are again considering the same experiment, that is we are throwing a die and we are calculating the probability of getting a number 8. We are saying the numbers on the die, they are 1, 2, 3, 4, 5 and 6. So when we are talking about the probability of this event, the event we are saying getting a number 8, so we are saying probability of E. From this it is clear that we can never get the number 8. So the number of the favorable outcomes, it is 0. The total number of possible outcomes, it is 6. The answer we are saying it is 0. So we are saying that probability of getting 8 in a single throw of die, that is equal to 0. So these kind of events which can never happen, these are called the impossible events, and their probability it is 0. So we have two cases. One is when we have the event which we are sure that it is going to happen, then that is called the sure event, and those events which can never happen, those are called the impossible event. The probability of impossible event, it is 0, and probability of sure event, it is 1. Next we have is the complementary event. So we are saying if E is any event, say it is suppose the experiment we are talking about, it is throwing a die, and the event we are saying it is getting a 4. So we are saying there is another event, we are saying it is not E, or sometime it is written as E bar. This event is not getting a 4. It means not E is an event which occurs only when E does not occur. These can be represented by this, or it can be represented as E dash. So this event E dash, it is called complementary event to E, and we have the property over here that probability of occurrence of E plus probability of occurrence of E naught, that is equal to 1. So why we are saying so? If suppose I am saying E is getting a 4, E bar or not E, it is not getting a 4. So when we are talking about some event, when we are going to do some trial, or we are talking about some probability, either this event will occur or this event will occur. One of these two will always occur, and this thing is showing that we are sure that one of these two events will occur. This thing is showing, this thing is shown over here, this one is representing this thing. So we are saying that probability of E, that is probability of occurrence of an event, that is equal to 1 minus probability of non-occurrence of that event. Now the next thing we have is that we are talking about the probability of occurrence of an event. We are saying in the denominator part we are having it is the total number of events. So either there can be, we are talking about a case when the probability of E, we are saying the minimum number of favorable events that we will have it is 0 and the maximum number of favorable events that will be n. So this is the case when we are talking about it is the sure event, and this is the case when we are talking about it is the impossible event. So what we get is that probability of occurrence of an event, it can be greater than equal to 0 and always less than equal to 1. That is the probability, the value of probability, it lies between 0 and 1. If probability of E is equal to 0, E is called impossible event. If probability of E is equal to 1, E is called a sure event. Then the next term we have studied is probability of non-occurrence of E. It is probability of not E, that is equal to 1 minus probability of E. So based upon these definitions and formulas, we are going to solve some problems. So the first question we have is, a coin is tossed once. What is the probability of getting a head? So we have tossed a coin. So the total number of possible outcomes, we are saying either it can be head or it can be tail. So the total number of possible outcomes, it is 2. We are calculating the probability, the event we have, it is getting a head. We are talking about the event we have, E we have, it is getting a head. So the number of favorable events over here, out of these two, the number of favorable events, it is 1. So using the formula that probability of H, that is probability of getting a head, that is equal to total number of possible outcomes, it is 2, and on the numerator we have number of favorable outcomes, it is 1. This is the number of favorable outcomes. Now the next question we have is, a die is thrown once. What is the probability of getting a prime number? So we are saying when we throw a die, then all possible outcomes of this is 1, 2, 3, 4, 5 and 6. So total number of possible outcomes, it is 1, 2, 3, 4, 5 and 6. So total number of possible outcomes, it is 6. We are saying the event we are talking about, it is getting a prime number. This is the event E. So what are the favorable outcomes? We know 1 is not a prime number, 2 is a prime number, 3 is a prime number, 4 is not a prime number and 6 is not a prime number. So the number of favorable events we have, it is 2, 3, 5. That is the number of favorable events we have, it is 3. So the probability we get, it is total number of events. In the numerator we have favorable number of events. So the probability we have, it is 1 by 2. Now the next question we have is, a die is thrown once. What is the probability that it shows? The first part, it is A3. So we are saying the all possible outcomes on throwing the die, it is 1, 2, 3, 4, 5 and 6. So the total number of possible outcomes, it is 6. When we are talking about the event that A3 comes, so the favorable number of events, number of favorable events, we are talking about number of favorable events, that is equal to 1. So the probability of occurrence of this event E1, we are saying the probability of occurrence of this event E1, it is the favorable events, it is 1, the total number of events, it is 6. Next, in the second case, we are saying a 5 will occur. So a 5 will occur means we are talking about, this is the event E2. So the number of favorable events, again it is 1. So we are saying the probability of occurrence of E2, it is 1 by 6. The third case we are talking about, it is an odd number. So when we are talking about the odd number, the favorable events we have, it is 1, 3 and 5. These are 3 events which are favorable. So how many number of favorable events we have? 3. The event we are talking about, that the outcome is an odd number. This is the E3 we are saying. The favorable outcomes, they are 1, 3 and 5. Number of favorable outcomes we have, it is 3. So the probability we have, it is the favorable outcomes divided by the total number of possible outcomes, and the answer we obtain, that is equal to 1 by 2. Next we are saying a number greater than 4. This is the event E4 we are talking about, and we are saying the number greater than 4 means the favorable outcomes we have, it is 5 and 6. Number of favorable outcomes, it is 2. We are saying the number of favorable outcomes in this case, it is 2. The total number of outcomes we have, it is 6. So the probability of getting a number greater than 4, the probability of this event E4, that is 2 by 6, that is equal to 1 by 3. Next is a die is thrown once, find the probability of getting an even prime number, a multiple of 3. So all possible outcomes, a die is thrown once, so all possible outcomes 1, 2, 3, 4, 5, 6. The number of possible outcomes, it is 6. We are talking about two events. First is the event E1, that we obtain a prime number. Second event given to us, it is the event E2, that it is the multiple of 3. So what are the possible outcomes for E1? It is 2. So number of possible outcomes, this is the favorable outcome we are talking about. So number of favorable outcomes in this, for this event, we are saying number of favorable outcomes for E1, that is equal to 1. That is only one number is there. So the probability we will get, the total number we have, it is 6. So the probability we will get, it is 1 by 6. For the second case, we are saying the favorable events we will have, it is multiple of 3. It means either it is 3 or 6. So number of favorable events, we are talking about the event E2. So the number of favorable events, it is favorable outcomes we are saying, not events, it is favorable outcomes, it is 2. So the probability, the total number of events we have, outcomes we have, it is 6. So the probability we get, it is 2 by 6, that is equal to 1 by 3. Next is two coins are tossed simultaneously. What is the probability of getting at least one head? So when two coins are tossed simultaneously, the favorable outcome or all possible outcomes we have, it is H, H, T, T, H, T and TH. Now the event we are talking about, it is at least one head we are getting. We are getting at least one head. This is the event E we are talking about. So the favorable outcomes that we have, we are saying HH contains at least one head, HT contains at least one head, and TH contains at least one head. So the number of favorable outcomes, it is equal to 3. So the probability we get, it is equal to number of favorable outcomes 3, the number of all possible outcomes, it is 4. So by dividing these two values, we obtain that the probability of getting at least one head is 3 by 4. Next we have is 3 unbiased coins are tossed simultaneously. Find the probability of getting exactly 2 heads, at least 2 heads, and at most 4 heads. So we have to write all possible outcomes. Now the method to write all possible outcomes, it is, we are saying 3 coins are tossed. So we are writing it is H, 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 then it is T, T, T and T. What we have done? We have written this H 4 times. We have written this T 4 times. Next we are going to write H, H, T, T, H, H and T, T. This is method I am telling you how you can write all these values. So we are saying we have written 2 times it is H, then 2 times T, then 2 times it is H and then 2 times T. Next we are writing it is H, T, H, T, H, T, H and T. So by writing in this way, we can write all the possible outcomes. So the total number of outcomes we have, it is equal to 8. So this is the method. This method you can remember, or you can use to write all possible outcomes when 3 unbiased coins they are tossed, and we are saying the total number of possible outcomes over here, it is 8. Now in this question we are talking about 3 events over here. First event we are saying E1, it is getting exactly 2 heads. Event E2, this is the event E2, it is at least 2 heads. And third event we are talking about E3, it is at most 2 heads. So when we are talking about exactly 2 heads, so we are saying, look at this event over here, this outcome, then this outcome. These are the 3 outcomes in which we have exactly 2 heads. These are the 2 heads, these are the 2 heads, and these are the 2 heads. So the number of outcomes for this event, the favorable outcomes we have, it is 3. The total number of outcomes, it is 8. So the probability we are getting for this event E1, it is 3 by 8. Coming to the event E2, we are saying the favorable event is at least 2 heads. We are saying this first case over here, it has at least 2 heads. At least 2 means we are saying it has 2 or 3 heads. Next, this case is there, it has at least 2 heads. At least 2 head, it is 1 head, then at least 2 heads. So the number of favorable outcomes, now it is 4. So the probability, it is 4 by 8, that is the number of favorable outcomes divided by the total number of outcomes, and the answer we obtain, it is 1 by 2. For the event E3, we are saying the possible values we have, we are saying it has at most 2 heads. At most 2 means either it can have 1 head, or we are not starting with 1, we are saying either it has 0 heads or 1 heads or 2 heads. We are talking about the case, this is at most 2 means either it has 0, 1 or 2 heads. So now look at these cases over here. We are saying this first case, it has 3 heads, so this is not the favorable event for this. Rest all the cases, we are saying at most 2, there are 2 heads, there are 2 heads, there is 1 head, there is 2 head, 1 head, 1 head, there is 0 head. Even this is the favorable for this, that it has at most 2 heads. This is also the favorable outcome for this event E3. So the total number of favorable outcomes we have, it is 7. Only this first is not the favorable in this case, rest all other they are the favorable outcomes. So we are getting the probability over here, it is the number of favorable outcome, it is 7, and total number of outcomes, it is 8. So the answer we are getting, the probability we are getting, it is 7 by 8. The next question we have, cards numbered 11 to 60 are kept in a box. So the first thing we have is suppose we have the cards from the number say 11 to 15. So we are saying it is 11, 12, 13, 14 and 15. So how many cards are there? We are saying it is 1, 2, 3, 4, 5. So it is not 15 minus 11, but it is 15 minus 11 plus 1, that is equal to 5 cards. This is important to note over here. The general mistakes that students commit over here, that they write 15 minus 11 cards and the answer they write there are total 4 cards. This is wrong, but there are total 5 cards. So similarly, when we are saying the cards are numbered from 1 to 60, so the number of cards we will have, it is 60 minus 11 plus 1, or we are writing it is 60 minus 10, that is equal to 50. So there are the total number of cards we have, it is 50. Next, it is given that if a card is drawn at random from the box. Now a card is drawn at random from the box, so we will get any number out of this. So the number of possible outcomes, it can be any number from 11 to 50. So the number of possible outcomes, it is 50. Next is find the probability that the number on the drawn card is an odd number. So we are saying this is the event E1 we are talking about, that the number on the card, it is the odd number. So how we are going to count the number of favorable events? We are saying the numbers now we will have, they will be, we are talking about the odd number. So the numbers we will have, it is 11, 13, 15, 17, so on up to 59. One method is either you have to manually calculate the how many numbers are there. The second thing, you can use the formula for AP, because this sequence we are talking about, this is an AP whose first term A is 11 and the common difference D is equal to 2, and the nth term we are saying that is equal to 59. So we want to calculate the value of n, and the formula we know, Tn, that is equal to 59, that is equal to A plus n minus 1 D. The value of A we have, it is 11 minus n minus 1, and the value of D we have, it is 2. So on solving this, the value of n we obtain, it is equal to 25. So we are saying that the number of favorable outcomes, it is 25. That these numbers, the odd numbers from 11 to 60, it is 25 numbers are there. So the answer for probability we will get, it is equal to the number of favorable outcomes, it is 25, total number of outcomes, it is 50. So the answer we are getting, it is equal to 1 by 2. Next we are saying is the second event we have over here, it is a perfect square number. So perfect square means which is square of some natural number. So the numbers we have, if we are considering the first square, that will be, if we are talking about 1 square, then 2 square will be 4, 3 square will be 9. These numbers, these are not present in this list. Next we have, it is 16. Next is 25, it is 5 square. Then 4 square is 30. We have 4 square, it is 16. 5 square, then 6 square, and then 7 square, it is 49. Then 8 square, it is 64. 64, and numbers after these are not present over here. So the number of favorable outcomes we have, it is equal to 4. These are the 1, 2, 3 and 4. These are the 4 favorable outcomes. So the probability we will get in this case, it is favorable outcomes, it is 4. The total number of outcomes we have, it is 50. So the probability we get, it is 4 by 50, that is equal to 2 by 25. Moving on to our next slide, we have the event E3 is the event that the number on the drawn card is divisible by 5. So we have the numbers from 11 to 60. So we are talking about the numbers divisible by 5. So that will be 15, 20, 25, 30, 35, 40, 45, 50, 55 and 60. So we can count these numbers. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10 numbers. So we are saying the favorable number of outcomes, it is equal to 10. If suppose we are given the number, say from 10 to 500. So it is difficult to count these numbers manually. So what we are going to do, we will use the formula for the AP. We will say the first term we will have over here, it is 15. The common difference D we have, it is 5. Tn we have, it is 60, and we can calculate the number of terms, and the answer in this case we are getting, it is 10. So the number of favorable events, it is 10. The total number of the favorable outcomes, it is 10, and the total number of outcomes we have, it is 50. So the probability we get over here, it is 10 by 50, that is equal to 1 by 5. So this is the probability of getting a number divisible by 5. Next we have is, let E4 be the event that the number on the drawn card is a prime number less than 20. So we are saying we want to write all the prime numbers from 11 to 20. So these are the numbers we are talking about. It is 11, 13, 17 and 19. So the number of favorable events we have over here, it is 4. So probability of getting a prime number less than 20. The favorable events, number of favorable events, it is 4. Total number of outcomes, these are the favorable outcomes, number of favorable outcome 4. Number of favorable, total number of outcomes, it is 50. So the answer we get, it is 4 by 50, that is equal to 2 by 25. This is the probability of getting a prime number less than 20. Next is a box containing 100 red balls, 200 yellow balls and 50 blue balls. There are 100 red balls, 200 yellow balls and there are 50 blue balls. If a ball is drawn at random from the box, find the probability that it will be a blue ball. So we are saying the total number of balls we have, it is 100 plus 200 plus 50. The answer we have, it is 350. So we are saying the total number of all possible outcomes is equal to total number of balls, that is equal to 350. We are saying we have to, the event we have, it is that a blue ball comes out, that a blue ball is drawn. So the number of favorable events, the number of blue balls, it is 50. So the number of favorable events, it is 50 in this case. So the probability we will get, it is 50 by 350, that is equal to 1 by 7. Second we are talking about, it is the not a yellow ball. Out of this 350 balls, we are saying the number of yellow balls, it is 200. So not a yellow ball, it is the number of balls which are not a yellow ball, it is 150. So corresponding to this event, the number of favorable events we have, it is 150. So the probability getting a ball which is not a yellow ball, it is 150 by 350, that is equal to 3 by 7. Next is neither yellow nor a blue ball. So we are saying neither it is a yellow nor it is a blue ball, it means it is a red ball. The number of red balls we have, it is 100. So we are saying the number of favorable events now, favorable outcomes we are saying, the number of favorable outcomes, it is 100. The total number of outcomes, it is 350. So the answer we get over here, it is 2 by 7. So probability of getting a ball which is neither yellow nor blue, it means it is a red ball. We are calculating the probability of drawing a red ball, it is 2 by 7. Next is a bag contains 5 red balls and some blue balls. I talk about there are some blue balls. So let us suppose that there are X blue balls. If the probability of drawing a blue ball from the bag, it is thrice that of the red ball. So what is the probability of drawing the blue ball? The number of blue balls, it is X. The total number of balls, it is 5 plus X. The probability of drawing the red ball, it is 5 over total number of balls, it is this. So what is given to us is that this probability over here, that is X upon 5 plus X. This is equal to 3 times 5 over 5 plus X. 5 plus X gets cancelled. So what we are left with is X is equal to 15. That is the number of blue balls in the bag, it is 15. Next we have is a bag contains white, black and red balls only. There are 3 kinds of balls in a bag. A ball is drawn at random from the bag. If the probability of getting a white ball is 3 by 10 and that of the black ball is 2 by 5. The probability of getting a black ball, it is 2 by 5. Then find the probability of getting a red ball. So we are talking about an event. We are saying the event, we are saying that the ball drawn is red. Then there is another event E dash or E bar. We are saying that it is not a red ball. If it is not a red ball, it means either it is a yellow ball or it is a not yellow, we are saying either it is a white ball or it is a black ball, because there are only three kinds of balls in the bag. It is white, black and red. So what we get is that the probability of occurrence of E plus probability of non-occurrence of E, that is equal to 1. So we are saying that the probability of E plus, we are saying either it is a white ball or a black ball. So the total probability we will have, it is 3 by 10 plus 2 by 5, and that is equal to 1. This thing is also mentioned over here, that probability of getting a white ball plus probability of getting a black ball plus probability of E is probability of getting a red ball, that is equal to 1, because these three events, these are the only possible events, and occurrence of one of these, it is a sure event. So on solving this, we will get the value of P is equal to 1 minus 7 by 10, that is equal to 3 by 10. So we are saying that the probability of occurrence of this event of getting a red ball, it is 3 by 10. Next is, if the bag contains total 20 black balls, then we have to find the total number of balls in the bag. Now from the first part, what we get is that probability of getting the white ball, it is 3 by 10. Probability of getting the red ball, it is also 3 by 10. These are the number of favorable outcomes divided by the total number of outcomes. Total number of outcome means this is number of white balls divided by the total number of balls. This is number of red balls over total number of balls. It means what we get is that the number of red balls, that should be equal to number of white balls, and let both these values, these be equal to x. Now it is given that there are 20 black balls. We are given that there are total 20 black balls. So the probability of getting the black ball, 2 by 5, that should be equal to the number of black balls over total number of balls. Number of black balls plus red balls plus white balls. On solving this value, the answer we will obtain, it is this value gets cancelled over here, it is 10. So we get 20 plus 2x is equal to 50. So this gives us 2x is equal to 30. So the value of x we obtain, that is equal to 15. We are saying the value of x we have, that is equal to 15. That is equal to number of red balls, that is equal to number of white balls. So the total number of balls in the bag, it is equal to 15 plus 15 plus 20, that is equal to 50 balls. So there are total 50 balls in the bag. Now the next question we have is, two different die are rolled together. So when we are throwing the two different die together, the possible outcomes we have on the first die, suppose we are getting 1. The first die we are saying we are getting 1. On the second die we can get, it is 1, 2, 3, 4, 5 and 6. So we get this first list of numbers. Now on the first die we can get, it is 2. So on the second we can obtain, it is 1, 2, 3, 4, 5 or 6. Similarly on the first die we can obtain, it is 3. On the first die we can obtain, it is 4, 5 or 6, and if we list all these numbers, we will get this collection of possible outcomes. Now the total number of outcomes we have 6 over here, 6 over here. So the total number of outcomes we have, it is 6 into 6, that is equal to 36. These are the number of all possible outcomes. Next, the first event that is given to us is that the sum of the numbers on two dice is 4. So the favorable events in this case, for the event E1, we have the favorable events. From the first list we are saying 1, 4 is the number for which the sum of the two numbers it is 5. From the second list this 2, 3 is the number. From third row this 3, 1 is the number, and from the fourth row this 4, 1 is the number for which the sum of the two numbers it is equal to 5. So the number of favorable events we are saying it is equal to 4. So the probability we get it is 4 by 36. 36 is the total number of events, and the answer we obtain it is equal to 1 by 9. So this is the probability of occurrence of the event 1. Now for the second part, we are moving on to our next slide. We are saying the event E2B, the event of getting an even number on both dice. Even number on both dice means we are talking about out of this first row no number is possible because the first term we have it is 1 over here. From the second we are having the terms, this is 2, 2, 2, 4 and 2, 6. Next we have 4, 2, 4, 4 and 4, 6. Next we have it is 6, 2, 6, 4 and 6, 6. So the number of favorable events we have it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of favorable events it is, favorable outcomes it is 9, and the total number of outcomes we know it is 36. So the probability we have it is 9 by 36, that is equal to 1 by 4. So this is the probability of getting even number on both dice. The third case we have the event E3 we are talking about, it is event of getting a doublet. So doublets we have over here, this 1, 1 is the doublet, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. We are talking about these values. These are the doublets over here. So the number of possible or the favorable outcomes we are saying it is 6. The total number of outcomes it is 36. So the probability of getting a doublet it is 6 by 36, that is equal to 1 by 6. Now the next question we have is two dice are thrown at the same time. Find the probability that the sum of the two numbers appearing on the top of the die is more than 9. So if we list all the numbers on throwing the two die, as we have seen in our previous case, we have listed all these numbers. So we are saying the total number of events that we will have, the possible outcomes, the total number of possible outcomes that we can have it is 36. Now we are saying the sum is more than 9. So sum is more than 9 from this row it is not possible, from the second row it is not possible, and from the third row it is not possible. So we are saying this number 4 and 5 it makes 9, then it is 4 and 6, 5 and 6, 5 and 5, 6 and 6, 6 and 5, 6 and 4. So the number of favorable outcomes it is 1, 2, 3, 4, 5 and 6. We are saying the number of favorable outcomes it is 6. So probability of getting a sum more than 4 it is 6 by total number of outcomes it is 36. So the answer, the probability we get it is equal to 1 by 6. Next question we have is a piggy bank contains 150 paisa coin. It contains 150 paisa coin. Next 50 rupee 1 coin. Next 20 rupees 2 coin and 10 rupees 5 coins. So the total number of coins we are saying it is 100, 50 paisa coin, 50 rupee 1 coin, then 20 rupee 2 coin and 10 rupee 5 coin. So the total number of coins we have it is equal to 180. This is the total number of coins. If it is equally likely that one of the coins will fall out when the piggy bank is turned upside down. So this thing is given to us that we are considering that it is equally likely. We are considering all coins of same shape and dimensions, and the possibility of coming all the coins out of the piggy bank, it is given to be same. So we are saying find the probability that the coin falling out of it is a 50 paisa coin. So there are 100 coins, 50 paisa coins. The total number of coins, it is 180. So the probability we get, it is 100 over 180, that is equal to 5 by 9. Next is the value more than rupee 1. The value more than rupee 1 means either it is a rupee 2 coin or it is a rupee 5 coin. So total coins we have, it is 30, and we are dividing this value with 180 to get this probability, and the answer we obtain, it is equal to 1 by 6. It is 30 by 180, that is equal to 1 by 6. The third case we have, it is value less than rupee 5. It means we are talking about these coins over here, that either it is a 50 paisa coin, rupee 1 coin or rupee 2 coin. So total number of coins, it is 170. This favorable number of outcomes, it is 170. Total number of outcomes, it is 180. So the probability we get, it is 17 over 18. And the last we are saying a rupee 1 or rupee 2 coin. So when we are talking about rupee 1 or rupee 2 coin, the number of favorable outcomes, these two are the favorable outcomes. The number of favorable outcomes we have, it is 50 plus 20, that is equal to 70. The total number of outcomes we are saying, it is 180. So the probability we are getting, it is 7 upon 18. So the answers for this event E3 and E4, these are shown on our next slide, and these are the probabilities: 7 over 18 and 17 over 18 and 7 over 18 corresponding to these two events. Now the next question we have is, a game consists of tossing a 1 rupee coin 3 times. We are saying a 1 rupee coin, it is tossed 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result, that is 3 heads or 3 tails, and loses otherwise. We have to compute the probability that Hanif will lose the game. So all possible outcomes when we are talking about, it is H, 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 T, 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 T. Then it is H, H, T, T, H, H, T, T. Then it is H, T, H, T, H, T, and H, T. We are saying we have 3 times these coin, 1 rupee coin, it is tossed 3 times. So these are all possible outcomes. So the number of all possible outcomes, it is 8. And we are saying he will lose if he is not getting all the 3 heads and all the 3 tails. So he will lose if this is not happening and this is not happening. So the number of favorable events in this case, these are the number of favorable events, and the number of favorable events in this case, it is 6. So the probability of occurrence of these outcomes or this event, it is 6 by 8, that is equal to 3 by 4. Another way of solving this is, we are saying he will win, Hanif will win the game if he will get 3 heads or 3 tails. So the favorable events for this case, it is H, 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 or it is T, T, T. So the probability we are getting, it is 1 by 4. Now the probability, if this event we are writing, it is E. So probability of non-occurrence of E, that is equal to probability of 1 minus probability of E. The answer we are writing, it is 1 minus 1 by 4, that is equal to 3 by 4. So it is up to you that how you want to solve this question. You can directly write the favorable number of favorable event, it is 6, and you can get the answer, it is 3 by 4. or you can solve it in this way, that you are writing the event E consists of H, H, H and T, 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 and then you use this formula to calculate the answer. Now the next question we have is, one card is drawn at random from a well shuffled deck of 52 cards. So we are talking about 50, total number of cards we have, it is 52. So the total number of possible outcomes, it is 52. So what is the probability of getting a king? So how many kings are there? We are saying there are total 4 kings, and the total number of cards we have, it is 52. So the answer we get for this, it is, the probability we have, it is 4 by 52, that is 1 by 13. Next we have second part we have, it is a red 8. So it is given that it is red also and it is 8 also. So the number of cards which are red and which are 8, it is 2. Total number of events, it is 52. So the probability we get, it is 1 by 26. Next is a spade. We have seen how many number of spades are there. There are 13 spades. Total number of cards, it is 52. So the probability in this case, it is 1 by. Now the next we have, it is a red card. The number of red card we have, it is, the total number of red cards that we have, it is 26. Total number of cards, it is 52. So the probability we get, it is equal to 1 by 2. Next part we have, it is the 6 of the clubs. So the, how many 6 of the clubs are there? There is only 1 6 of the clubs. So the probability we get, it is 1 by 52. And last we have, it is the face card. And we know that how many face cards are there? There are 12 face cards. There are 3 cards we are saying that are face card. It is king, queen and jack. So 4 kings are there, 4 queens are there and 4 jacks are there. So total number of face cards, it is 12, and the total number of cards we have, it is 52. So the answer we will obtain is 3 by 13. So the total, the probability of drawing a face card, it is 3 by 13. Now the next question we have is, one card is drawn from a well shuffled deck of 52 cards. So the total cards we have, it is 52. Find the probability of getting a king of red suit. How many kings are there of the red suit? It is 2 kings of red suit are there. There are total 4 kings. 2 are of red suit and 2 are of black suit. The total number of possible events we have, it is 52. So the probability of the occurrence of this event, it is 1 over 26. Next is a queen of black suit. Again there are 2 queens of black suit. The total number of possible outcomes, it is 52. So the probability we have, it is 1 by 26. Next is a jack of hearts. So how many jack of hearts are there? There is only 1 jack of hearts. The possible number of all outcomes, it is 52. So the probability of a jack of hearts, it is 1 by 52. And the last part we have is a red face card. So if we look at the cards, then we can see that the total number of face cards, it is 12. Half of them are red and half of them they are of black suit. So red face card, they are 6 in number, and the total number of possible outcomes, it is 52. So the probability we get, it is 3 by 26. So these are the possible probability. These are the probabilities in these cases. Now the next question we have is, a card is drawn at random from a well shuffled deck of 52 playing cards. Find the probability that the card drawn is a card of spade or an ace. So if we are talking about the spades, the number of spades we have, it is 13. In these 13 spades we have an ace. Apart from this, we have 3 more ace. Apart from this ace of spade, we have 3 more ace. So the total number of cards we are talking over here, it is 16. The all number of possible outcomes, it is 52. So on dividing these values, the probability we get it is 4 by 13. So this is the probability of getting a card of spade or an ace. Second, we are talking about a black king. We are saying how many kings are there? There are total 4 kings. 2 are of black color and 2 are of red color. So a black king means there are 2 black kings. The number of possible outcomes, the total number of possible outcomes, it is 52. So the probability we have it is 1 by 26. Now the third case we are talking about, it is neither a jack nor a king. So we are saying we are talking about the card which is neither a jack nor a king. So the total number of cards we have it is 52. We are saying we have removed out of this the what is not possible. Jacks are not possible. There are 4 jacks and there are 4 kings. So we are saying that we are not interested in jacks and kings. So the number of favorable events that we will have, that is equal to 44. The total number of possible outcomes, the number of favorable outcomes, it is 44. Total number of outcomes, it is 52. So the probability we obtain, it is 11 by 13. Now the last part we have, it is either a king or a queen. Either it is a king or a queen. So we are saying what are the possible number of favorable outcomes? The favorable outcomes, we are saying there are 4 kings and there are 4 queens. So the number of favorable outcomes, it is 8. The total number of outcomes, it is 52. On dividing these two values, the probability we will get it is 2 by 13. The probability we obtain in this case, it is 2 by 13. The next question we have is, one card is drawn at random from a well shuffled deck of 52 playing cards. Find the probability that the card drawn is, first case we have either a red card or a king. How many red cards are there? We are saying there are total 26 red cards. In these 26 red cards, 2 kings are there. Now how many black kings are there? There are 2 black kings. So the favorable number of events, the total favorable number of events, it is 28, and we are dividing this value with 52. That is the total number of possible outcomes. So on solving this, the probability we will get it is equal to 7 by 30. Next we have is neither a red card nor a queen. So we are saying how many red cards are there? There are 26 red cards which include 2 queens. How many queens are there? There are 2 black queens. So the total number of cards we are talking about over here, it is 28, which are either, these are 28 we are saying, either they are black or either they are red, not black, either they are red or they are the queen. The total number of cards we have, it is 52. So the favorable number of events, it is 52 minus 28 is equal to 24. The number of all possible outcomes, it is 52, and on solving this, the answer we will get it is 6 by 13. So this is the probability of getting a red card or a queen. Next we have is all the black face cards are removed from the pack of 52 cards. We are talking about black face cards. How many face cards are there? There are 12 cards. How many black face cards are there? There are 6 cards. These are removed from the 52 cards. So the number of remaining cards we will have, it is 52 minus 6. That is equal to 46. So the total number of cards we are talking over here, it is 46. The remaining cards are well shuffled and then a card is drawn at random. Find the probability of getting a face card. We are saying black face cards are removed. Now how many face cards will be left over here? It is 6 face cards are left. We are saying the possible number of all outcomes, it is 46. So the probability we get, it is 6 by 46, that is equal to 3 by 23. Second, we are talking about red card. We are saying black face cards, these are removed. So the number of red cards we will have, it is 26. All the total number of possible outcomes, it is 46. So we are writing it is 26 by 46, and the answer we get, it is 13 by 23. The probability we get, it is 13 by 23. Now the third we are talking about, it is black card. We are saying the total number of black cards that we have, the total number of black cards that we have, it is 26. Out of this, the black face cards, these are already removed. So the remaining number of black cards we have, it is 20. Number of favorable outcomes, it is, in this case, it is 46. So the probability we get, it is 10 by 23. The last part we have, it is a king. When we are talking about a king, we are saying the cards that are already removed, they are the black face cards. So there are two black kings that are removed. So what we are left with is, we are left with is two red kings. These are the number of favorable outcomes. The total number of outcomes in this case, it is 46. So the probability we get, it is equal to 1 by 23. So we are saying that probability of getting a king in this case, it is 1 by 23. Next is red queens and black jacks are removed from a pack of 52 playing cards. It is given that red queens and black jacks are removed from the pack of 52 playing cards. So the remaining number of cards we have, we are saying red queens, there are two red queens and two black jacks. These are removed from this card. So it is 52 minus 4, that is equal to 48. So we are left with total number of cards remaining over here, it is 48. Now after reshuffling these cards, a card is drawn at random. We have to find the probability that the drawn card is a king. So the number of kings we have, it is 4. The total number of cards we have, it is 48. So the probability we have, it is 1 by 2. So we are saying the probability of getting a king, it is 1 by 12. It is not 1 by 2, it is 1 by 12. Second we are talking about, it is of red color. We are saying how many cards are there of red color? There are 26 cards, but two red queens, they are already removed. These two red queens are already removed. So the remaining number of red cards we have, it is 26 minus 2, that is equal to 24. The number of favorable events, outcomes in this case, it is 48. So the answer we get, it is equal to 1 by 2. So the probability of getting a red card, it is 1 by 2. Next we have is a face card. Now we are saying the two queens and two jacks, these are removed. Total number of face cards we have, it is 12. Out of these, two queens and two jacks are removed. So we are remaining with 8 face cards. We are saying the total number of favorable events we have, it is divided by 48, and the answer we obtain in this case, it is equal to 1 by 6. So we are saying the probability of getting a face card, it is 1 by 6. Now the last part we are saying is a queen. So we have removed two queens. Total number of queens we have, it is 4. We have removed two queens. So the remaining queens we have, it is 4 minus 2 is equal to 2. The number of favorable events, or the total number of outcomes, we are saying it is 48. So we are saying the probability we have, it is 2 by 48, that is equal to 1 by 24. So this is the probability of getting a queen. Next is from a pack of 52 playing cards, jack, queens, kings and aces of red color are removed. So how many jack, queen, kings and aces of red color are there? There are 2, 2, 2 and 2. So the total card removed, that is equal to 8. The remaining cards we have, it is 52 minus 8, that is equal to 44. So the remaining cards now we have, it is equal to 44. Now we have to find the probability that a randomly drawn card, it is a black queen. So 2 queens of red color, they are already removed. So the remaining queen, number of queens we have, it is 2. The total number of possible outcomes, it is 44. So the probability we get, it is equal to 1 by 22. This is our first case. We are saying that probability of getting a black queen, it is 1 by 22. Second, we are saying it is a red card. Now total number of red cards we have, it is 26. Out of these all red cards, 8 red cards have been removed. So the remaining number of red cards we have, it is equal to 18. The total possible number of events, favorable events or outcomes, we are saying it is 44 over here. So on dividing these two values, we get the answer, the probability we get, it is equal to 9 by 22. So this is the probability of getting a red card. The third we have is a 10. The third part we have to calculate, it is a 10. So we are saying the number of 10s we will have, it is equal to 4. The number of possible outcomes in this case, that is equal to 44. So the probability we get, it is equal to 1 by 11. Now the last part we are saying a picture card. So a picture card means we are talking about the jack, queen and king. So we are saying how many picture cards are there left. We have removed 2 jacks, 2 queens and 2 kings. So the total number of picture cards we have, it is 12, out of which these three have been removed. 3 means 2 jacks, 2 queens and 2 kings are removed. We are saying 6 cards are removed. So the remaining number of cards, it is 6. Number of possible outcomes, it is 44. So the probability we get, it is 6 by 44, that is equal to 3 by 22.